Hello, my mathematicians. I hope you're having a great day. We've had a wonderful week looking at patterns and how trying to find things that look the same and noticing them. Our brains love patterns, whether that's when we're reading words or if we're working with numbers. And we're going to kind of be working with patterns sort of today. So I'm actually going to teach you a new word. That is, if you haven't heard of it before, which I'm guessing you may not have because it's kind of a big word. So let's take a look at this. I actually wrote it down for you. Equivalent. Boy, that's a big word. In fact, I didn't know how to spell it. So I was doing the segmenting equivalent, four syllables, and I finally said, Alexa, how do you spell equivalent, to make sure I was right, because I wanted to be right for this. Oh, now she's talking to me. Equivalent. So we're going to find equivalent names for numbers. So in order to find equivalent names for numbers, I need to know what equivalent means. And equivalent kind of sounds like the beginning of a math word that I do know. So equal. Do you remember what equal means? Equal means it's the same, right? If you had a scale and you want things to be equal, you want them to be the same. So we're going to be talking about equivalent numbers. Boy, that's a lot to wrap your head around. Let me explain a little further. Okay, so equivalent name for numbers. So I have some coins here and pennies, and doesn't matter why I chose pennies. I'm looking for a number of things. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pennies. Okay, I could write 10 that way. But you know what? I could write 10 another way. Let me see. I could write 10 like this. Do I still have 10 pennies? I sure do. But I've kind of split them up. So now I have 3 plus 1, 2, 3, 4, 5, 6, 7. 3 plus 7. 3 plus 7 is equal to 10. Let me see if I can do another one. Nope. Okay, I moved them over again. So now, do I still have 10 coins altogether? Yep. But this time I have 6 on this side. You could see that kind of easy because I see 3 and 3, and I knew that was 6. And I see 2 and 2 over here, so that must be 4. So there's an equivalent number for 10. Now let's see. Let me do, how about I do this? What is that now? 1, 2, 3, 4, 5 plus 1, 2, 3, 4, 5. So I never changed the amount of pennies on this board. They were always 10. But I came up with different names for 10, didn't I? I came up with 3 plus 7, or 6 plus 4, or 5 plus 5, or I could do this. 1 plus how many? You know? 9. I could do this. 10 plus 0, or 0 plus 10. Let me tell you something that is actually something that would be a good thing to practice today, is if you can figure out all the numbers that make 10, let me just tell you that math will be so much easier. And I didn't figure this out until I was a grown-up and started teaching this and realized that I can really think about numbers and I can kind of do things more in my head, where before I used to have to get, my marker out and carry a 1 or something. Now I'm able to kind of move those numbers around in my head because I really got to know this well. So we're going to be doing this kind of stuff a lot this year, figuring out tens and sums of tens and how to make 10 and equivalent names for 10. But let me show you what you're going to be doing today. This is kind of a fun one because we're going to be playing a game called the Broken Calculator game. Have you heard of it before? I can't remember if this was something that you did in first grade, and I should remember because I did teach first grade for a while. But they might ask you to make 10 on your calculator. Just like that. Can you see it? 10? But they might say you can't use the number 1. The number 1 key's broken, so you can't do it. So I'm going to clear that out. How can I make this calculator say 10 without pressing in the 1 and the 0? Well, I can use an equivalent. Let's see if we can press that in. What is 3 plus 7? 10. Did I ever use the 1 key on this? I didn't. Try it again. Let me try 6 plus 4, shall I? So I'm not going to press the 1. 6 plus 4 equals, I got another one, 10. Yay! Of course, we did 5 plus 5, didn't we? So I'm just going to try that one too. 5 plus 5 equals 10. So I was able to make those numbers without having to use that 1 key. So in your math journal today, you've got a page, and it's on, let's see, page 4. And they are going to let you look and see if you can find ways to show different numbers without pressing a key that's broken. Now, if you have a calculator, you can do it. But to be honest with you, when I did this in my classroom, I hit all the calculators. You know what I said? I want you to use this calculator, because your brain can be a calculator. And just the more you use it, the smarter it gets. So see if you can use this calculator. But just to show you how that will look, I'm going to use this one also to check it. So in this example that they give us, they say to show 17, but they say the broken key is 7, so I can never press 7. So first of all, let's see what they did. They did 11 plus 6 equals, and yep, it equals 17. They did 20 minus 3, so 20 take away 3 equals, and they did it. And look at this one. I know, and we've played this magic number in my classroom quite a bit on whiteboards. It's super fun, isn't it? And gotten so many different answers. I love it. But here they did 8 plus 8 plus 1. And in your brain, hopefully you remember, if you know your doubles facts well, 8 plus 8 is 16 plus another 1. So let's see if that works. 8 plus 8 plus 1 equals 17. Awesome. So now I have to come up with ways to show 3 with the broken key being 3. So I can't just plug in 3, but I have to get that to show up on my calculator. So let me think about how I might do that. I know, like, I could do 1 plus 1. Oops, that's only 2. Plus 1. Will that equal 3? I think it will. Or 2 plus 1. Or maybe, oh, doubles facts. 6 take away what? Do you know? 6 take away 3 might be 1. I could do 4 take away 1, couldn't I? 4 take away 1 is 3. So I have to check and see, because the broken key is 3, so I couldn't use 3. So, I used 3 there. I'm gonna get rid of that one. 4 plus 1. Let me think if I can think of another one. Could I do 5 minus something? 5, 4, 3. Okay, so 5 minus 2. And that's how I could show 3. So let me just check it out on my calculator so that you can see it. So 1 plus 1 plus 1, we know that's going to be 3, right? Yay! 2 plus 1 equals 3. 4 minus 1 equals 3. 5 minus 2 equals 3. So did I do it? I did it. Yay! So now it's your turn. And you're going to have to do this. So this is on page 4 again. And it asks you to show 20, but you can't use a 2. So again, as you start writing down as many ways as you want, and I would say several means more, 3 or more. So you need to have at least 3. If you want to do more, you can. The smaller you write, the easier it'll be, but you want to make it neat so that we can see it really good, okay? So you're going to have to show 20, but the 2 won't work, okay? This one says to show 22, but the 2 can't work. This one wants you to show 12, but the 1 is broken. And then, it's kind of fun when you get to be your own teacher. You can make up your own. You can pick whichever number you want, You can tell us what number's broken, and it should be something in the answer, right? So you notice this one had 2s, this one had 2 and a 0, this one had 1 and a 2. So whatever, like if you pick the number 100, you're going to want to say you can't use a 1 or you can't use a 0, something like that, okay? But we would like you to do this page. So page 4 is what you're going to work on today by yourself. And then, as always, when you're finished, you can make an awesome choice. And I did want to show you one other thing that's really fun, and it's called the two-fisted penny game. Sometimes you may have done it with paper plates. I think they had one that was called the paper plate game last year. But if you remember, like I had all these pennies out. Do you remember how many I had before? This is a great practice, by the way. And like if you have a grown-up with you to help you, your grown-up, this would be a good practice. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you're going to start with 10 always. And then you're just going to put your hand over some of them. Okay. And you try to guess what's under your hand. So I have 4 over here. So how many do you think are in my hand? Got it? Let's see. 1, 2, 3, 4, 5, 6. Did you do it? Let me try another one. Ready? I'm going to do this one. Okay, I've got one in my hand, or I've got some in my hand. We'll see how many I have. Over here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. How many is in my hand, do you think? 1. That was kind of an easy one, wasn't it? So you got 10. But the more you practice this game, the better you're going to be at sums of 10. So right now I have 3 or 5. What do I have to add to 5 to get to 10, you know? 5. So you can play this game with a grown-up or a sibling or anyone you want and practice those sums of 10. Because like I said, those are the building blocks. That's what's going to get you really good. So for today, page 4, working on that broken calculator game. We're going to be in to hear you and to talk to you about some great math stuff. And we will see you soon. Have a great day.